Yes, I'm going to talk about cocoa agroforestry systems, and this is what I'm working on here in Côte d'Ivoire. I'm usually based in Montpellier. I'm a research scientist at CIRAD in a research lab named ABSys. And I'm working here. I'm based here in Côte d'Ivoire since last year, where I can work directly with the cocoa farmers. And my main objective here is to identify climate resilient cocoa-based systems. So this is what I'm going to talk about. So if you have any problem to hear me, do not hesitate to stop and to ask me to repeat. I don't know. I don't have any view of the room. I don't know. Yeah, I'm like talking by myself here. So the outline of this presentation here. So I will talk a little bit about my research lab. Then you will see what are the agronomical needs for growing cocoa trees. And we will also see how climate change is already impacting cocoa in Côte d'Ivoire, or how it's going to impact cocoa in Côte d'Ivoire in the next future. Also, I will present a few mitigation and adaptation practices that cocoa farmers are already using. And we will then focus on cocoa agroforestry systems. We will see how they contribute to the adaptation and to the mitigation of climate change effects. I will then conclude with a few information about the main challenges that we should bear in mind when we are designing or promoting cocoa agroforestry systems, and what are the challenges of research, such as the design of multi-criteria assessment to evaluate cocoa agroforestry systems. So before we talk about cocoa, I would like to introduce my research team. I'm part of a team named ABSys for biodiversified agrosystems. We are a group of 50 permanent persons that belong to CIRAD, INRAE, Institute Agro, or the Mediterranean Agricultural Institute. Our work focuses on agroecological transition of perennial crop-based cropping systems. We are working together to produce knowledge, but also tools and methods to assess and to design those cropping systems. And by perennial cropping system, I also mean agroforestry systems. So we studied a wide range of perennial cropping systems in Mediterranean and also in tropical regions. So here you are, for example, all the cropping systems we are studying. You have cocoa agroforestry systems, of course, but you also have coffee agroforestry systems, oil palm agroforestry, rubber agroforestry, coconut, and olive and other Mediterranean agroforestry systems. So now we are going to talk about cocoa. So cocoa tree is a very very important tree, cash tree, because it is it's been used to produce chocolate, and you all know how this is important if you eat chocolate for Christmas or for Easter, for example. So this tree is an evergreen tree that grow up to 5, 6, or even 7 meters tall. And the pods that are the fruit, they grow directly on the trunk and on the branches. So this is particularity of the cocoa. One thing about cocoa tree is also that it has a very large genetic and morphological and physiological differences across the known cultivars. So this is very important, this is very interesting, and there are actually 2 main international cocoa collections around the whole world, and they are located in Costa Rica, Trinidad. They are in charge of the conservation and the management of the cocoa diversity. So traditionally, where will cocoa, what type of environment will cocoa tree grow in? So you have this tree is a few years ago was naturally growing in humid tropical areas. So this tree is very drought sensitive and need temperature between 23 and 26 degrees. Also, the rainfall should not be less than 1.2 thousand millimeters and should be very well distributed because this tree is very water sensitive and drought sensitive. So the drought period should not be very long, but be as short as possible. It is also wind sensitive, so with very damaging wind impact. Is of course a shade tolerant tree because it was originally growing in Amazonian forests, but it's also sun tolerating crop. Cocoa needs very deep soil with good drainage. The entire production is mainly threatened by a lot of pests, actually, including insects, fungi, and bacteria. The main cocoa pests and diseases that we know are black pod, cocoa swollen shoot virus, mirids, and cocoa stem borers. So black pod is, for example, on the left of the screen, it is a fungus, while cocoa swollen shoot disease is a virus carried on by a mealybugs. It is one of the most devastating disease caused by a virus in Cote d'Ivoire here or in Ghana, because there is actually no solution for this virus other than cutting out all the trees. So only cocoa swollen shoot virus can eradicate half of the cocoa production areas. Other than cocoa pest disease attacks, we also have physiological problems that cocoa tree will face. And this problem is called cocoa sherrel wilt. It is a physiological problem that can generate a huge loss of the potential yield. This problem is called the sherrel wilt because it is affecting only the very new fruit, the fruit that have less than 10 centimeters. The fruits suddenly they dry and they die. This for example, in the picture is a dry sherrel hanging on a cocoa tree. So we generally discover the dry sherrel and there is nothing we can do about it. It's actually too late. The phenomenon is very important because it can result in up to 90% loss of the total production. And we don't really know why this problem can appear. We don't really know why we have cocoa sherrel wilts and why we don't have a lot of cocoa sherrel wilts sometimes. But we assume that this can be because of an incomplete pollination or a physiological response of the cocoa tree to an internal or to an environmental stress. If there is, for example, too much stress, the tree will select a few fruits that will reach maturity, while the other fruits will be aborted. So now let's take a look at the cocoa production countries, and most of the world's cocoa originate from the West African cocoa belt. What I call West African cocoa belt is the cocoa production region from Sierra Leone to Cameroon. So most of the world's cocoa originate from this part of the world, almost 75%. And Cote d'Ivoire is the largest world cocoa supplier with 43% of the world production. And this crop is not only important for the whole world, is also very it has an economical importance for Cote d'Ivoire because it is the main export crop. It is the country's largest foreign exchange provider, and there are almost 5 million people that will benefit from the cocoa production. There are almost 5 million people that will have income from these cocoa productions. This will represent the 1/5 of the Ivorian population. So this is very, very important. So cocoa production is also 7.5% of the gross domestic product and 10% of the government tax revenue. Yet, even if the country has that important economic worldwide, it has also played a key role in deforestation and biodiversity loss in Cote d'Ivoire. Since its introduction in Cote d'Ivoire, the production was mainly based on a slash and burn model. It's an extensive agricultural model. And this graphic here on the left look at two very important agricultural indicators that are land harvested and the pollution levels. And you can see that with those data obtained from the FAO's official statistics, the cocoa production increase is a result of the expansion of the cocoa cultivated areas. So in Cote d'Ivoire, where, for example, we have more than 2 million hectares of cocoa plantation, there is a loss of 4.5 million hectares of forest since 1986, between 1986 and 2015. And this suggests that the practices in cocoa, the way cocoa are produced in Cote d'Ivoire are not sustainable, and they are leading to a loss of the forest area. Also, using a modeling approach, we have seen that the global earning potential of cocoa in Cote d'Ivoire is the higher compared to Cameroon, for example, or compared to Ecuador and other cocoa producing regions. So when we discuss with farmers, they report a different range of perceived climate change effects. And some complain about the rainfall. They think rainfall is irregular. Others argue that the change in climate are related to heat and drought. We try to understand those perceptions and to confirm or not those perceptions. So some of the perceptions are confirmed by the observation of historical climate data. So here on this graphic, you have the difference in annual rainfall in Cote d'Ivoire from 1950 to 1999. So from the first 2 decades on the top of the graphics, the weather in Cote d'Ivoire was very, very wet. During that period, you had, for example, rainfall between 1.4 thousand millimeters and 2.4 thousand millimeters. But since 1970, the weather station records are recording very low precipitation value, and the worst is on the north part when you can see even less than 1,000 millimeters of water. So these results, these observations suggest that even if there is still an active discussion and a high uncertainty about climate change indicators, this observation confirm that there is already some difference, that the farmers are already experimenting climate change and probably the climate change impacts. So now using global climate models for long-term projection, we were able to predict the climate change by 2050. And using the IPCC business as usual scenario, meaning that there is no mitigation of the greenhouse gases emissions, the model prediction for 2050 indicated that only a slight decrease of precipitation will appear in Côte d'Ivoire. This is the graphic at the top right. So only a very few degrees decrease of the precipitation. And in 2050, the strongest decrease in precipitation will be seen in the west of Côte d'Ivoire, with decrease ranging from 20 to 40 millimeters. It's not very much for an annual rainfall. But also the models predicted an impressive increase of the mean annual temperature. Is this graph at the bottom right of the graphic. Indeed, temperature will increase progressively by 1.7 to 2.1 degrees in the south region and can reach 2.5 degrees in the north regions. Also, these results suggest that the cumulative dry month is going to decrease. The cumulative dry month is a climate change indicator. It corresponds to the maximum number of months with less than 100 millimeters precipitation. And this indicator in the modeling results seems to decrease from 4 to 3 months in 2050. And this is the positive result and the positive assumption of these modeling results. However, even if we do not have a decrease of precipitation, even if we do not have much more dry months, we still have an increase of potential evapotranspiration, and this is because of the combination of higher temperature that is not compensated by a change in the rainfall, and is only partly compensated by the decrease of the drier season and the favorable rainfall distributions. So there is still a problem of growth because we have more evapotranspirations. So now, considering the impact of those climate variation and dryness, there are increasing evidences like this table. There are evidences that indicate the climate change is already affecting cocoa in Côte d'Ivoire. All around the world, but particularly in Côte d'Ivoire. And this results in higher mortality, higher yield decrease, and more diseases. So here in Côte d'Ivoire, for example, what we have seen last year is from November 2015 to March 2016, we had a very long period of dryness and a strong harmattan. Harmattan, I don't know if everyone knows harmattan. It is a dry wind blowing from the east and the north. And the result of that climate modification was a decrease of the cocoa production at the end of the campaign. In 2016, cocoa production indicated a decrease of 10 to 12% compared to the previous campaign. And this corresponds to more than 200,000 tons of cocoa beans that will not be produced, even if there is a global demand growing up. So in order to quantify how the change we are already seeing will affect the suitability of cocoa production here in Côte d'Ivoire, there were simulations made based on global climate models and on the business as usual scenario of ABSys. So those modeling approach show that there will be a significant reduction in the geographical area that would be suitable for cocoa production. Almost 90% of the potentially suitable areas will show decreasing pattern by 2050. This reduction will mainly be related to the drier climate conditions rather than to increasing temperatures. Indeed, this simulation suggests that the cocoa trees were more sensitive to climate drying than to the temperature increase. But the dry climate we already know that the dry climate actually is a combination of the temperature increase that is not compensated by the annual rainfall. Then the drier climate will be a result in augmentation of the evapotranspiration. So this suggests that in 2050, there will be a reduction in water available for cocoa plants, and this will lead to a disappearance of cocoa that have less than 20 meter altitude, like coastal area or savanna areas. And there is only a slight positive effect on the higher elevation areas. Also, in order to assess the importance of taking early adaptative action in the Ivorian cocoa sector, the Ivorian cocoa production department, we estimated potential losses of a hypothetical scenario in which there is nothing that is changing, like no action is taken against the negative effect of climate change on cocoa. We still produce like we are producing right now, and nothing is done. The simulation of this no action reveal that if the climate change condition of 2050 occurs, the predicted condition of 2050 occurs today, like we are in the condition we are already growing cocoa, we will lose more than $1.1 billion per year. And this is not only affect the cocoa producing country, but will also affect the cocoa consumers. So other than impact on economic or production, climate change is also expected to have an indirect impact on the propagation of pests and diseases, and particularly the cocoa swollen shoot disease. So here on the left, you have a list of the potential effect of temperature rise on insects and pests. So it seems like climate change can modify the behavior of the pests by increasing their distribution and their growth rate. So climate change can also modify the synchrony between crop and pests, the interaction between some pests and their natural enemies. So this will probably result on the emergence of a higher number of pests and the emergence of new pests. And as an example of those potential impacts, in Brazil, it was predicted that the expansion of the moniliasis is one of the most destructive diseases affecting cocoa in the world. And it has been confirmed that under climatic conditions of 2020, 2050, and 2080, this disease is going to expand largely. So also it's expected that climate change will affect the cocoa swollen shoot virus disease by modifying the microclimate of the cocoa plantation, because the mealybug that carry on the cocoa swollen shoot disease from one tree to another, it is a very little bug, and they like increasing in very dry environments. For example, the mealybug species named Planococcus citri, they like very warm and dry microclimates, and their population are becoming increasingly large, especially in Cote d'Ivoire. And this might be the reason why in Cote d'Ivoire, compared to Ghana or other countries around here, the proliferation of Planococcus citris is observed, and then the augmentation of the cocoa swollen shoot disease is also observed in Cote d'Ivoire. It is very increasing here in Cote d'Ivoire. And one other assumption is that the symptoms of cocoa swollen shoot disease will also increase because the more intense dry season will lead to significant water stress. Okay, so knowing that those diseases are going to increase in the next future, now we will see how they are actually managed. So there is currently no solution to manage cocoa swollen shoot disease. You have the photo on the left is the a plantation of damaged cocoa swollen shoot disease. So this disease will dry the cocoa and defoliate the cocoa tree. And the only solution right now is to cut all the infected trees and to replant all the entire system. So this is a very costly solution. And the goal of this strategy is to eradicate, to eliminate the source of the infection, and sometimes to plant very tolerant cocoa varieties. And for example, in 2018, the national authority that regulates the cocoa industry in Côte d'Ivoire is called the Conseil Café Cacao. They launched a national program that is called Projet d'appui à l'arrachage et à la replantation. This project has a goal of cutting 100,000 hectares of cocoa that has been infected by cocoa strains. It's already a lot. It's very, very lot. So even with these very radical methods, we still observe a rise of the cocoa swollen shoot disease across the country, across the cocoa regions. And this might be because the cutting programs are not very effective. Actually, there might be some affected trees that are not identified very early. So that's a very big problem. So even if we are losing a lot of areas, we are destroying a lot of effects, we still have cocoa swollen shoot that is rising all across the country. Okay, so now let's see how the farmers are currently coping with those climate change effects. They are implementing different strategies, and those strategies are either implemented at plant scale or plot scale or at farm scale. One of those strategies are the use of climate resilient varieties. And today, during the previous talks, we had already seen the interest, the importance of breeding for climate change tolerance. And we know that it is a promising adaptation option. For cocoa particularly, there is a wide genetic diversity that might be used, and that leave room for the development of climate change tolerant varieties. But despite this great potential, cocoa full genetic diversity has been underused for breeding resilient, climate resilient varieties. But that's very surprising, but there are many reasons for that. Even if there are many programs developing varieties or trying to propose hybrid of cocoa, they are more focused on the disease tolerance variety than on climate tolerance varieties. Because one of the reasons might be because breeding for climate resistant varieties is much more complex than breeding for a disease resilient variety. Also, the adaptation strategy implemented at plot scale are mainly water irrigation, crop fertilization, and pesticide use. So irrigation, yeah, is still a very interesting option in some places for where the weather is very dry, but it's costly and is unlikely to be adopted by a large number of farmers here in Côte d'Ivoire. So there are other studies that have been established on the hypothesis that mineral nutrition, in particular potassium, and pesticide application might play a very important role in the mitigation of climate change. And the concept is that a healthy cocoa tree with very good balanced nutrition and very well applied pest management products is more likely to be resilient to abiotic stresses. But there is still not many farmers using those approaches. There are many reasons for that. So one of those reasons is that currently the use of the fertilizer are very costly. Also, they do not know very well what are the soil characteristics, what do the soil need actually, and what are the timing of the fertilizer application. Now, considering the entire farm, there are different approaches to mitigate or to adapt to climate change. One of those approaches is crop diversification. So the diversification of crop is the association of several different crops on the same farm in order to achieve more regular farmer incomes. And a cocoa farm here in Côte d'Ivoire, for example, has cocoa tree, but also other crops like corn, yam, cassava, bananas, fruit trees like mangoes, avocado, some beans, or some other vegetables for the family to eat, or maybe for the farmer to sell. So the work we are doing here highlight that the crop diversification is usually progressive. When farmers are facing, for example, a very large impact of climate change, like low soil fertility or climate drying up, they will progressively replace the demanding crop, which is cocoa. If the area is not suitable for the cocoa production anymore, they will replace the demanding crop by a less demanding crop such as coffee or even rubber trees. Also, this is a combination of the local demand. If there is a market for coffee, for example, or for rubber tree, they will propose to associate rubber or the demanding crop than other crops. It's also depending on the potential. Is the farmer has the farmer had a good training of the management of the new crop they are going to implement it or not? It's also a gender related. It seems like when the farmers are women, they prefer some crops for the diversification than others. And here on the right, We studied the proportion of cocoa and non-cocoa income among farmers along a climate gradient, not in Cote d'Ivoire, but in Ghana. The situation is very similar. And we found out the cocoa farmers in dry region are more likely to adopt crop diversification. The reason might be because farmers in dry environments, they face a very strong impact of climate change, and then they need diversification. They diversify their production because they need to increase the income and to maintain the food security. Okay, now we will talk about agroforestry systems in particular. So to limit those negative climate change impact on cocoa production, farmers also implemented not just crop diversification, but the use of shade tree in their plot in the form of agroforestry systems. So it is defined, agroforestry system is actually defined as an agricultural production activity that's combined on the same plot annual or perennial crops with trees, and that generates fruit, wood, and other products, as well as the ecological services. And this is a traditional land use pattern that has been practiced on all continents for centuries. So agroforestry is a traditional land use approach, and it can be a sustainable model for production if all factors and interaction between crop associates are carefully managed. So most of the time, agroforestry systems are criticized for their lower production than monocrop systems, but they, however, combine many other ecological services such as the nutrient cycling, the microclimate management, the weed control, the pest and disease control, and the increase of the soil quality. So this is a more stable and more resilient over time agricultural model than monoculture with respect to climate change. So here are the main benefits, a list of the main benefits from cocoa agroforestry and how they can mitigate and adapt to help farmers mitigate and adapt to climate change. So there are different pathways. They can be the environmental pathway, the microclimatic pathway, the increase of cocoa production, or even the entire farm production. There are also socio-economical pathway that agroforestry systems use to increase the adaptation capability of the farmers. So, for example, they exhibit a very higher carbon stock in vegetation, not only vegetation, but also in the soil, as well as this better soil fertility in comparison to annual to other monocropping systems. Shade tree also create a very different and better microclimate for cocoa plants by mitigating temperature and by providing a moisture atmosphere and then a cooler atmosphere in the system than monocrop systems. In terms of production, agroforestry systems provide diversification of agricultural income, and the different agroforestry species are potentially affected differently by extreme climate events. So this will result in an improvement of the resilience of the farmer income and the entire resilience of the system. So in the next slides, I will focus on some of those benefits. I will explain how they actually provide those benefits and I will illustrate only the benefits I highlight here. So is it okay?
Karen?
Are you still there? Oui.
Yeah. Maybe you can move to the conclusion. We are still here. Because of our timing. It's okay for you.
Okay, maybe I will show just a few slides, a few example of how agroforestry system contribute to the adaptation, and I will speed up. Okay, so agroforestry system can provide opportunity to reduce greenhouse emission by sequestering carbon in tree and also in soil. And this study here, we measure the long-term carbon dynamic in different cocoa agroforestry systems, and we also compare this to previous forest or previous savanna land. So cocoa-based agroforestry systems were able to store the cocoa-based agroforestry systems in savanna areas were able to store as much carbon in the above ground biomass than the cocoa-based agroforestry system in forests. And this is mainly because of the large associated trees. So this is important to mind. The type of the tree, the size of the tree is very important for the ecological services we are trying to reach. We are seeking. We have also seen that cocoa agroforestry systems have the ability to sequester carbon in the soil, not just in the biomass, but this is organic carbon in the soil. So using different cocoa systems in Ecuador with modeling approach, here we simulated the impact of different management systems, different pedoclimatic conditions, different cocoa variety, and different cocoa producer type. The main results are in highlands, in Amazonia, the soil organic carbon stock is positive in drier areas. This is because of intensity of rainfall erosion. But the net soil organic carbon at the end of the simulation is not the same if you consider a drier area or a highland, for example. So in highland, in coastal area, the net soil organic carbon content is positive. Now, regarding soil quality, we've seen that in a comparison of shade tree species, how shade tree species will affect soil fertility. Yeah, okay. How shade tree species are affecting soil fertility and cocoa yields in different cocoa agroforestry systems. And we've seen a very increasing effect of shade tree on soil chemical properties, and the improvement depend of the tree. It was very low on the fruit tree, but medium on the legume tree, and a very high on the different type of timber trees. So these results were suggesting that according to the tree species, we could offset the nutrient removal caused by cocoa bean. So yes, the tree selection is very important. Not all agroforestry systems are going to provide those benefits. And using a different approach, using a multidimensional meta-analysis here, there was an investigation of the difference between cocoa agroforestry systems and monoculture. So the agroforestry systems outcompete monocrops for most environmental and economical indicators. So there is, for example, a decrease in mean temperature and attenuates extreme temperature. Okay, let's jump to the reduction of pest and disease, the impact of pest and disease. So this might be through a different approach. It can be a modification of the microclimate or a blocking effect. And here is a significant result where we've a comparison of the mean population distribution and the percentage of the light transmitted through the tree canopy show that shading can reduce the pressure of the pest, can reduce pest pressure. But this should be not for every disease, because for example, fungus can be we can have an increase of fungus on the shade tree. So this can be a problem when there are a lot of agroforestry, a lot of tree in the plot. Yes, in this here we've seen that the long-term productivity of the cocoa agroforestry system can be increased. Like they will produce for more than 60 years in comparison of 20 or 30 years in monocrop production. So we are almost at the conclusion of this presentation.
Yes, it would be great if we had time for discussion.
Yes, I understand. We need to. Yes, Sebastian?
Yeah, I was saying that it would be great to have time for discussion. If you like to move to your conclusions, then we can share and discuss
I'm
all together.
At the end of the presentation. Here, I would just like to say that it's important to bear in mind that there might be some risk posed by a poorly designed or managed cocoa agroforestry system. If the trees are not carefully selected, they could worsen the effect of climate. So they can even be competitive with cocoa production for resources, for water, for light, for example. Also, here I would just like to say that the climate change impact on farmers in Ivory Coast is not only affecting farmers, it's also all the food chain. So we need to promote a very sustainable cocoa agroforestry systems by working directly with the policy makers, even if there are a lot of actual method and policies that are contributing to the development of cocoa-based agroforestry systems, but we are still working on the good method and the good tools to assess the trade-off between cocoa production and the other ecological services. So my main conclusion will be that, yes, we have cocoa production that is providing income for more than 1/5 people in Cote d'Ivoire, and this production is going to withstand very higher temperature in the next very next year. And in addition, we will also have very direct impact of climate on direct or indirect impact of climate on pests and disease. But among all adaptative strategies, environmental, economical, and social benefits, and they can then be used to mitigate, they can also be used to mitigate climate change for the reduction of carbon emissions. It appears that these tools can be useful even if there is still room for increasing the global productivity. So this might lead to stabilization of the current production and the reduction of the deforestation. So yes, I will stop here, Sebastian. If
yeah, thank you very much.
All the entire audience.
Yeah. Yeah, thank you very much. I know it's not that easy to you don't have feedback and you cannot see as a room. So thank you again. So if the student have question, or if you do have question to the student, we really agree to have a time for the discussion.
Yes, we do have.
You should get close to the microphone. Yeah, please stay with us.
Okay. Thank you so much, Karen, for the very rich and detailed presentation. I have a question regarding the quantification of climate change impacts, because one of the challenges that we had while we were preparing for the projects was actually on-ground quantification, because we saw in scientific literature each like temperature rise and rainfall decrease or change, what can scientifically have on coffee plants, but on the ground, especially in Veracruz and Chiapas, we really lacked quantification in the literature review. And I was wondering if CACA research also has the same lack of quantification or not, and if so, why do you think this lack of quantification is due to? Thank you.
Yes, we are also, this is a very interesting question. We are also facing those quantification, the difficulties here on the assessment of the cocoa yield loss, for example, or the cocoa response to climate change mitigation. And the main reason is also because the climate change is not affecting only one indicator, only one process. There is a combination of many different processes. For example, the temperature increase will affect not only the physiological response of the crop, but also the entire farming. So the farmer might already been adapting to the observed climate difference. But what we as researchers are focusing on is to compare the systems, like at the plot scale. We try to see what will be the difference if the climate was not changing, if the weather, the temperature was not increasing, if the rainfall was not decreasing, how the plots would react, what will be the yield, what will be the cocoa quality, and so on. So we are trying to find solution at the plot scale. This is the reason why we can easily find a comparison paper between monocrop and agroforestry system. But when you try to compare at a regional landscape, at a regional plot, yes, it's more difficult to separate the effect of climate from the effect of the, for example, the other aspects of soil depletion, for example. So yes, we also have the same difficulty, but we try to find solution at the plot scale when we can really truly manage the tree and the crop.
Okay. Thank you.
Other question?
Yes.
Anna?
Hi.
Please.
Hi, I have another question. It is regarding the genetic variability you talked about in your presentation for cocoa. I was wondering if this diversification of genetic variability in the trees has any advantages, and if they, in that case, if they could be replicated for the case of coffee, as we talked about in our presentation, in the case that we can introduce different varieties. Thank you.
Yes. Okay. So yeah, the advantage of cocoa is that the genetic variety is higher, is very large compared to the genetic variety you will see for coffee, for example. So this is we have already seen, for example, how cocoa tree, how different genotypes will respond to an increase of temperature when they use greenhouse, for example. And we have already those observation. Also, other observation we have is actually the cocoa tree is grown in a wide different regions. In comparison to coffee, we do not we are not only cocoa tree are not located only on the higher regions, so there is still room for the improvement, the natural improvement of the response of the tree. So this is a little bit different from coffee. We have more genetic variability, and with cocoa it can be produced in a wide range, different climatic regions.
Thank you.
Yeah, Alexis, please.
Yeah, I have a question. Thank you for your presentation. You speak about agroforestry, but for example, in Peru, there is some study that show that cacao in agroforestry are less productive because you have more disease, you have shadows, and the efficacy of agroforestry is linked to plot maintenance. So if the agriculture, the farmers able to make maintenance, it will be effective. But if not, and there's many farmers that there is poor farmers, so they don't have the budget to do so. So does the farmer have the economic capacity to carry out this work? And in your region, does the efficacy of agroforestry is linked to plot maintenance and cost?
Okay, yes. Thank you very much for your question. And I think this question raises a very important aspect of our work. It is how to quantify the trade-off of ecological services and yield production in agroforestry systems. I think this is a very the basis of your question, because yes, depending on the local condition, depending on the initial soil condition, and also depending on the type of the tree species that have been selected, agroforests can raise some important problems. You can have competition for water if the associated trees also need a lot of water. You can have a tree that's a host for some disease. If you choose those trees and not knowing the local needs of your plot or your farm, you might have a very much more problems than the initial cocoa production problem you are trying to resolve. So the agroforestry system I've tried to propose here is not a one mighty agroforestry system. It's not only one agroforestry system that can resolve all the problems. So they need to be adapted to the farm. They need to be adapted to the soil. They need to be adapted to what type of tree the farmer can actually manage. And regarding the management of the agroforestry systems, here we are mostly talking about smallholder. They have less than 2 hectares. So it's not like a very big farm producer or industrial production. So the problem is usually not about the economical aspect, but the training, how to trim, how to manage the tree, at what moment in the year they need to manage the tree, and at which rate they should cut some branches and so on. So the main problem is not an economical aspect. Is mostly a training question. Also regarding agroforestry systems, if you consider only the productivity, like the main yield production, you might see some decrease or some decrease on the shade tree association. But you need to consider the long term ROI, return of investments, we need to consider also that those agroforestry systems are mitigation climate change, so they are contributing to the carbon storage. So this is the beginning of my answer. The main problem is how we quantify the trade-off of those agroforestry systems. How we can say that the main ecological benefits are more interesting than the economical benefits.
Okay, thank you. Maybe one last question for the word to the students. So, Nathalie?
Yes, thank you for your presentation. I have several questions, actually. The first one is when you compared the adaptation strategy with the Macoba, you said that, in fact, when you have intercropping with Macoba, you increase the photosynthetic active radiation. And your comparison was with monoculture. So I don't see how you can include the PAR if you have more trees. Can you explain this?
Yes, as I was mainly focusing on the comparison of low density and high density, because in our system in Mexico is original agroforestry system. So I just made the mistake not to talk that when I'm saying high density Macoba, they permit better. Okay. Better it was compared to what is done in Mexico, not on the experiment.
Okay, okay. I was wondering whether it was diffuse and direct light, so it's just okay. And then you have talked about pest issues, but then from Karen's presentation, what we saw is that for cocoa, the problem is the synchronicity between plant phenology and insects. So I was wondering whether it was the same kind of problems with coffee. Can you expand a little bit on that?
The impact that we almost found on coffee pests and diseases was mainly related to temperature rise, but also on humid, what was related to temperature rise and humid condition in going up the altitude gradient, but we didn't find links to the phenological state of the coffee plant in relationship to the pest.
It was an extensive niche of, yes, of the insects. Okay, okay. And then my last question is I really enjoyed when you provide the limitations each time you show an adaptation strategy. And when you talked about mapping the vulnerable areas, you said that the main limitation was the uncertainty in the climate models. But don't you think this uncertainty is the same for all adaptation strategies? The problem of the uncertainty in the climate models, isn't this true for all adaptation strategies or not?
Yes, it's true for all adaptation strategy, but particular to the region of Chiapas and Veracruz, as there is a mountainous region, is that climate models are more uncertain on the mountainous region.
Okay, so you are targeting more the resolution of altitude in the models, yeah, as a problem. Okay, thank you very much.